Alright, so we're going to cover the quadratic formula in this video. A lot of you have probably used the quadratic formula or heard of it or remember it from Algebra 1, so hopefully some of this is review. So the quadratic formula can be used to solve any quadratic equation, so long as we first set the equation equal to 0. So we have a quadratic equation with ax squared plus bx plus c, and it's set equal to 0. That's an important part. Then we can solve for the x values, so these would be the x-intercepts, with this formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a song, but I don't feel like singing it right now. This portion that's under the radical sign is called the discriminant, and it tells you what type of roots you have. So if the discriminant is some number that's greater than 0, then the equation has two real solutions. So if we got like square root of 25, then we would have two real solutions because there's plus 5 and there's minus 5 from the plus or minus in the equation. If you end up with a negative under the radical sign, you have what are called two complex solutions. And we cover these later. For now, in this first set of problems, because we haven't learned about complex solutions, if you get a negative under the radical sign, you did something wrong. And if the discriminant is equal to 0, then you would have square root of 0. And the square root of 0 is 0. So this plus or minus becomes irrelevant because you're adding and subtracting 0. So at that point, it's just negative b over 2a is your one solution. And that's the vertex, right? Negative b over 2a. It's the formula for the vertex. So that would mean the vertex is on the x-axis. So we can use the quadratic formula to solve any quadratic equation, as long as you... Right, so any quadratic as long as one side equals 0. So for example, 2x squared plus 8x plus 1 equals 0. It's already set equal to 0, so we don't have to do anything extra from there. So we can just go straight to using the quadratic formula. Remember, this coefficient is a, this one's b, this one's c. So x equals negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 1 all over 2 times 2. So if we do some simplifying inside the radical, then 8 squared is 64, and 64 minus that product is 56. So it's the square root of 56 all over 4. And at this point, we do want answers in simplest radical form. Any problem that's not a word problem, we want to simplify the radicals as much as we can. So the square root of 56, remember, we could rewrite that as, this would simplify to the square root of 4 times the square root of 14. If you have your own way of simplifying radicals that you like better, that's perfectly fine. But this reduces to 2 square root of 14. So now we get negative 8 plus or minus 2 square root 14 all over 4. And then we can simplify those fractions a little bit. So one thing to remember about fractions is you can actually split a numerator over the denominator. So this is the same as negative 8 over 4 plus or minus 2 square root 14 over 4. And we could simplify 8 over 4 to 2, so it's negative 2 plus or minus 1/2 times the square root of 14. And this would be considered the most simplified form of the answer. So keep in mind, we got the answer. We got the answer up here, right? That's still technically the right answer. Over here is just the most simplified. So if you need practice simplifying radicals, I highly recommend it. It comes in handy throughout the year. On to number 2. So, of course, in order to use the quadratic formula, the equation has to equal 0 first. So we're going to move this 33 over to the other side. So now it's, well, really we added 33 to both sides. So 2x squared plus 25x plus 33 equals 0. So now a is 2, b is 25, c is 33. So one advantage to using the quadratic formula is it's always good to try and factor first. So if we had tried to factor problem 1, we would have been trying to find numbers that multiplied to 2 and added to 8, and there are no such numbers. So that one you have to resort to completing the square or the quadratic formula. In this one, we would have to find numbers that multiplied to 66 and added to 25, and those are big numbers, and I don't know my factors of 66 off the top of my head. So it's also not a bad time to just use the quadratic formula. So x equals negative 25 plus or minus square root of 25 squared minus 4 times 2 times 33 all over 2 times 2. And now if you evaluate and simplify inside the radical, you'll get plus or minus the square root of 361 all over 4. Make sure, I don't have enough space to write out all the steps of simplifying this thing, but make sure you can do that and make sure that you get 361 when you do. Otherwise you might be calculatoring wrong. So, square root of 361, if you type in your calculator, that is equal to a perfect 19. So now we can simplify this further, and I'm going to split up my plus or minus into negative 25 plus 19 over 4, and then negative 25 minus 19 over 4. Because both of these can now be simplified into a single rational number. And negative 25 plus 19 over 4 will simplify to $11. Oh no, 3 halves. That one goes to 3 halves. And negative 25, that's negative 3 halves. And negative 25 minus 19 over 4 goes to negative 11. Yeah. Okay, so on to the last group of problems. So this one's word problem. So we have this projectile motion problem. So a projectile is launched and its height is given, in meters after t seconds is given by this function. Y of t is negative 4.9 t squared plus 15t plus 6. And its horizontal distance is given by the function x of t equals 15 times t. So, what is the maximum height? So it's asking about height. So it's asking about height. That's this one, because this one tells me its height. It's a vertical height, right? And the maximum height of a parabola would be its vertex. So this is just asking me to find the vertex. So this is not a quadratic formula problem. But now that we've learned more things, it's good to kind of mix these things in. So, to find the vertex of this, we just need to use the negative b over 2a formula. So, the time would be, so that's the formula, right? So in this case, it's going to be negative 15 over 2 times negative 4.9, which comes out to 1.53 seconds. But that's not the max height, that's only the time it takes to get the max height. So to find the max height, I have to plug in 1.53. So I'm going to plug in 1.53 to this y function, and that's going to be, so that means negative 4.9 times 1.53 squared plus 15 times 1.53 plus 6. And that will come out to 17.47 meters. Again, make sure that you can plug this into the calculator and get the same number I did. Alright, when will the object hit the ground? So, if it's hitting the ground, that means that it has a height of 0. So again, we're asking about height, so I only need to worry about this vertical height formula. And if it's hitting the ground, then that means it's equal to 0. So negative 4.9 t squared plus 15t plus 6 equals 0. Now we want to solve for t. So now it's a quadratic formula problem. Helpful tip. Negatives are annoying. Negative a especially. It's annoying to deal with in the quadratic formula. You can use it, it's fine, you won't get the wrong answer, but it is annoying because then you end up with the negative in the denominator, and I don't like that. So, I'm going to multiply both sides of the equation by a negative 1. So everything is multiplied by negative 1. Right? And that's just going to flip the sign on everything. I think it makes the problem a little bit nicer. Now, negative numbers are so gloomy. They always get me down. So now it's 4.9t squared minus 15t minus 6 equals 0. So now it's quadratic formula. So t equals, remember this is A, that's B, that's C, that's a 6. Great. So 15, because it's double negative, so negative 15 makes positive 15, plus or minus the square root of negative 15 squared minus 4 times 4.9 times negative 6 all over 2 times 4.9. Alright, so again, if you simplify the inside of the radical correctly, and make sure that you can do that, you'll get square root of 342.6 all over 9.8. Okay, now, you don't have to simplify the radical, right? For two reasons. One, it won't simplify because it's a decimal, so we can't use our simplifying rules. And two, this is more important, we want to know when the object hits the ground. So we want that answer as some approximate decimal number, not as some number with a radical. If you tell me the ball hits the ground in 15 plus square root of 342.6 divided by 9.8 seconds, your response will be somebody giving you a funny face, because that number doesn't make sense. We want a value, right? So at this point, I'm just going to plug square root of 342.6 into my calculator, and it will spit out 18.51-ish, right? So now, we're going to get rid of that, and now it's negative 15 plus or minus 18.51. all over 9.8. And if you evaluate the plus and the minus correctly, and make sure you can do that, you would get t equals 3.41 and t equals negative 0.36. And we're asking how long does it take for the object to hit the ground, and the object did not travel back in time, so it can't be a negative time. So that one doesn't make sense. So 3.41 seconds is the correct answer. How far away will the object be from its launching point after it hits the ground? So at this point, now we're using that horizontal distance formula, because we want the horizontal distance that the object travels when it hits the ground. So that just means we need to find the x-coordinate after 1.53 seconds. And that would be 15 times 1.53, which equals 51.15 meters. All right, that's it.